All right. Okay. So happy Monday, and we'll take a look. I've posted your first, I guess, regular homework assignment here. Okay. I'll probably also post a data camp assignment as well. But I want to talk a little bit about the homework assignment. So, tripping on stuff. Um, so if you click homework one files and I have a typo here. RMD, QMD submission. So you will find I've got a instructions PDF, and then I have an output PDF. So what you're gonna wanna do is you're gonna download these things, but then make a folder, okay? Make a folder called homework one and put your files inside there. You don't wanna just put them all inside your downloads thing, okay? Or better yet, make a stats 15 folder somewhere, and then inside stats 15 make a homework one folder, and then download your files there. Okay, so I'm downloading this, the instructions, the QMD. There's like okay, you have to download this PNG. You might not have to download the CSV thing. Okay, so these are just simple examples of plots here, okay? And, okay. Anyway, you can open up the PDF with instructions, and this has instructions for you to follow. All right, and one of the first things it says is install the packages that we're going to use for our data. So you're going to copy this line of code, and you're going to run it in the console. Okay, do not put it into your QMD file. Okay, you'll just run it in the console, and this will install the necessary packages. And you might get an error message, or not an error message. All right, it says RTools is required to build R packages. Okay, well, I don't need to. All right, if it says, do you want to download something with RTools or something, just type in no. Okay, it should. These packages should install. Okay, just fine. No need to do that. All right. So anyway, so in the instructions PDF, you're going to just copy this line of code that says install.packages, and that should download that. And again, so don't put it in your Quarto document. Okay. Because if you put it in your Quarto document, every time you try to render your document, it's going to reinstall the packages, and it's going to like just slow down the rendering of your Quarto document every single time, and things like that. Okay. And then the other thing you want to do is after you've downloaded all of your files into your homework one, you're going to open up the QMD here. Okay. And you should be able to just click render. Okay. And if you click render, it'll take a couple seconds, and we're hoping no errors. Okay, so that's what we want, and then it should render it as a PDF here. Okay, and the stuff should, we hope, look fine. Okay, so that's going to be step one. Now, if you can't open it and just click render, right? Check and make sure you have all of the files inside your homework one folder. Okay, and then if you're getting some other kind of thing, come to office hours. All right. So I would say try this out today. Okay, and that way, if you encounter an error message or something, you can come to office hours and we can try to get it fixed right away. Please don't wait. So it's due a week from today. Please don't wait until Sunday. Okay, and then you download and then you encounter an error message. Okay, I don't have office hours on Sunday, and I don't want you to show up on my Monday office hours and be like, oh, I can't even get the thing to run and it's due in a few hours. So try it out today. If it doesn't work today, come to office hours later today or tomorrow or something. Earlier on is better. Okay. Now, if you procrastinate and wait till Sunday, you're still allowed to come to office hours on Monday, but just okay. And then anyway, as you work, you will just, with the Quarto document, you'll change it. You'll put your name, right? And then just kind of acknowledge this academic integrity statement. And then, yeah, you can say, I didn't use AI, or I did use AI, but only in the allowed ways or something, list them off, okay? This says, some of these things say part 1, textbook, chapter 2, exercise 3, okay? So what that means is you have to go to our Modern Data Science with R textbook, okay? Beep, 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 beep. Okay, and then you go to chapter 2, and then at the bottom, there's exercises. So under right here where it says 2.7, chapter 2, exercises, and it lists off some stuff. So like the full content of the problem. So for this one, it says textbook chapter 2, exercise 3, example of a compelling graphic display. I think also there's some stuff here. Part 1, textbook chapter 2, exercise 3. I think I've copied and pasted some of this stuff here, okay? And so for this, like, you'll go on the internet and you will find, some data visualization, okay? And there's, you can go to news websites. There's, if they put in graphics and stuff, you can check R's Data is Beautiful subreddit, of which there will be both good and bad examples, okay? And I want you to think about this, think about your answer here, okay? And again, compelling doesn't necessarily mean beautiful, but what it means is that the data visualization communicates something to the reader. And if the author is trying to make a point with their thing, then and you feel like you're getting the point of whatever it is they're trying to make, then I would say that's a compelling thing, okay? There is a thing, a New York Times graphic. If you have a New York Times subscription, the graphic is interactive, okay? And this is about birth control. And it to me, I thought it was fascinating, okay? And so the actual graphic is interactive. Now, if you don't have a New York Times subscription, then I have just a static version posted as one of the homework files here. And open it up here. Okay. But anyway, all right, I don't know why I can't open it, but it should open. Oh, there it goes. All right. All right, so this is just this is the graphic. You'll have to zoom in here. Okay. But this is like the rate of unplanned pregnancy for typical usage versus perfect usage and things like that. And it's like, oh man, it's a lot of for some of these it was way higher than I thought. Okay. Anyway, this is just asking questions about, so you can kind of see data visualization and answer them. All right, and the others, I think these are kind of just some beginning exercises as far as like getting your feet wet in terms of using ggplot to start making data visualizations. Okay. All right. So again, make a little folder, download your stuff into a folder, and then try rendering your Quarto document. And it should render. It should render, no problem. Okay. Well, you have to make sure you install the packages that have the data. Otherwise, you're going to run into like, there's no package with that. Okay. And if you encounter problems, come to office hours. So what I thought we could do is I was going to just do kind of a little bit of a demonstration. I don't know. I don't know if this is a live demo because I've already written up a lot of the code, but I wanted to kind of just walk through how we can use data visualization as a way to explore data, as a way to kind of, we ask questions and then we use a data visualization to see if we can answer that question. And then, because I would say data analysis and a lot of data science in the beginning part is just kind of this interacting with the data. It's this back and forth. I have a question, let's see what we can find in the answers. I've got another question, let's see what we can find in the answers, right? And there's a lot of different parts to it, and one of the most important tools is data visualization. Later on, we'll look at getting summary statistics, like calculating what's the mean and what's the standard deviation for these different things. And so that's coming a little bit later. And but there's this kind of this back and forth of, all right, let's look at our data. Let's ask a question. Can we even get an answer from that question? Now that I've asked this question, I got an answer. Do I have more questions? And there's kind of this back and forth. And so this is just kind of a short little thing. I think it's about the right length that we can do within our time together here. And so we're going to start off here. Okay, so I'm going to use, so the first thing we do is we're going to load up the tidyverse. So if you want to follow along, you can download and follow along. If you just want to watch me, that's also fine, okay? But we're going to load up the tidyverse. That includes all of the packages that do our plotting and some of our data kind of wrangling and manipulation there, okay? And then there's another data set called Gapminder. If you run, and I'm going to call library Gapminder, and this is going to load that up. If you run into an error about when you try doing library Gapminder and it says there's no Gapminder, then you'll have to do the install and you'll type in Gapminder there, okay? Here, I think my projector is just like the left edge is getting cut off there, so try. Okay. All right, so we're gonna load up our Gapminder data, and then I always say, hey, take a look at it. So we're gonna click View, all right, and we can also ask for help. Type in down here. Okay, help on Gapminder. And this pulls up some information about this, okay? And if we look at it, we can see the columns. We've got country, we have the continent, the year, the life expectancy, the population, and GDP per capita, okay? And we also have, it says this is an excerpt of the Gapminder data on this stuff for these different countries, and it says, okay, we've got 142 countries, 5 continents, years 1952 to 2007 in increments of 5, life expectancy at birth in years, population, and GDP per capita, U.S. inflation adjusted, et cetera, et cetera. And there's, the original sources here. There is some stuff. So, we got Afghanistan in, 1952, the life expectancy was 28. And, and then we have different countries. And so in 1952, a lot of these countries feel like they have really low life expectancies, and indeed they are low at life expectancies. The reason why some of these numbers feel so low, right? So like in Angola in 1952, life expectancy was 30, is because there's a lot of child mortality, and so you can have a lot of people reaching 70 years of age, but then if you also have a child dying at 1 year of age, okay, the average for life expectancy there would be what, 35, 36, right? So if you have high child mortality, even though you have some people reaching old age, the average is very low. Okay, and so you'll find in a lot of the data as healthcare improves and stuff, and you have massive reductions in child mortality, and you're going to see life expectancy make big improvements. Okay, there is something important to note in that a lot of the data had to be kind of filled in and guessed and kind of extrapolated. Okay, as far as the countries go, okay, they're kind of taking like the country that existed, I guess in 2007, and then they kind of go back in time. So for example, one of the countries listed is Bosnia and Herzegovina, okay? And it was part of Yugoslavia until 1995, okay? But you're not going to find Yugoslavia listed as a country. And then, if you look up Bosnia and Herzegovina, it's going to go back and, it has kind of extrapolated numbers as if like this country, if we could kind of take like the current borders and go back in time or something, like it's kind of its best guess, right? Similarly, like Germany, after World War II was divided into East Germany and West Germany, and then it was reunited in like 1990. And, in our data here, it just says Germany, okay, going back from 1952 up to 2007, as if like, completely ignoring the history that exists there. It just says, oh, here's Germany. And so it's just kind of like, if we had to guess what this stuff was, if we just kind of pretended that East and West Germany were already reunited back, during the Cold War and stuff like that. Okay, so issues with the data, and it's always, I guess, important to keep these things in mind. And despite some of the issues, it doesn't mean it's completely useless. It's just we have to keep this in mind. We can still kind of look at it and still gain some insight, right? Okay, so we're going to just start off by creating a very basic plot. And I'm just going to say, hey, you know what? Let's put GDP per capita on the x-axis and life expectancy on the y-axis. And we'll just go ahead and we'll plot this as a point. So we're going to do ggplot. Our data is Gapminder, right? So I could write data equals Gapminder, but again, the default is it's expecting your data to be your first argument and then your mapping to be your second argument. So here, my first plot is going to be ggplot, Gapminder, AES, and we're going to put GDP on the x-axis, y on the life expectancy on the y-axis, and we're going to plot it with geom points, okay? And then so I'll go ahead and I'll click the little run button to run this thing. Yes, a question? Is it not available under packages? So if you click the little install on the packages pane. If you click install, I think you can just type in Gapminder, I think, and then you'll click install. Is that working? You got it? Okay. Yeah, so if you don't have it, click the little install button, type in Gapminder. It should, I hope, install. Okay. So this is kind of our first plot here, and this is, it's hard to read. Okay, We just have a whole bunch of dots here, okay? And one of the issues, okay, is that as far as GDP per capita, we've got a few nations in here where the GDP per capita is like 90,000, 100,000, like these really kind of comparative to everyone else, really high numbers. And we can see there's just so many where, like, if this is what, 15,000, there's so many dots in here that are below 15,000. It's really hard to read, okay? That they're just kind of, all of these dots just get stacked on top of each other, and you can't even make out individual points in there, okay? So one of the issues is we are plotting, okay, the entire data set, of which there's 1,704 entries. What happened here? Okay. And, you know, basically each nation gets plotted, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times, okay? Because it's spanning from 1952 to 2007 every 5 years. So that kind of like that 55-year span, there's 12 entries, okay? And so every country shows up as 12 dots, and this is just all of them plotted all together. It's kind of tough to see, okay? So one thing is, let's filter just to 1 year, okay? And so for this, we can use the filter command, right? And so let me just show you how filter works. So let me just run a code cell here, and I'm going to do Gapminder. That's the data set. And then I use what's called a pipe, okay? The pipe is the vertical bar and the greater than sign, okay? Yeah. How do you do the vertical bar? Oh, okay. Yeah, on the American keyboard, it's the button above Enter. There's a backslash and then a vertical bar. So Shift backslash on my keyboard. I think there's you can do Command Shift M or Control Shift M. Does that work also? If you do Command Shift M or Control Shift M, does that insert a pipe? I don't know.
That's the percentile.
Oh, okay, yeah, that also works. Okay, this is an alternate pipe. Percent greater than percent is there's like two forms of the pipe. Okay, there is a small technical difference that I don't know. Okay, I do know there is a technical difference between the two. But yeah, so I think Command Shift M or Control Shift M is the shortcut to insert a pipe, and it either will insert this pipe or this pipe. There is a difference. I don't know what it is. For most times they play the same. Okay, and okay, so here's Gapminder, and I'm gonna just do. We're gonna use the command filter. Okay, and filter basically says filter the rows. Okay, keep only the rows that have a certain condition. Okay, keep the rows that match a condition. So in this case, we're going to say filter, I want only the rows where year is equal to 2007. So we write year equals 2007. Okay, and if I just run this is going to print out the table here, or we can say, oh, okay, here's the year, and now we can see there's only 142 rows, not 1,704, okay? And it's just basically one row per country, right? You can pipe this after you filter it down to year equals 2007. You can do capital V view parentheses, and then when you run this, it brings up the filter data into the kind of the scrollable format over here that we did, when you did view Gapminder, kind of something like that. You don't have to do that, okay? But that's what filter does, okay? So what I'm doing is I'm taking Gapminder, I'm filtering it just to the rows where it's 2007, and then I'm piping that into ggplot, okay? And so when you pipe data into ggplot, that takes place of the first argument, which is normally just your data set. So earlier when we called ggplot, it was ggplot gapminder data. Now we're saying for the data, take whatever we did up here. So in this case, we are filtering to year 2007, and we're piping that in as our data for ggplot. Okay. And then, so now I have X equals GDP per capita, Y equals life expectancy, genome point. And so now this is our scatter plot just for the year 2007. Okay, so just for the year 2007, now I have 142 dots, rather than 1,700. And so this is easier to read. Okay, is that all right? This filter operation. And so, you know, if you want to do a different year, okay, you say, hey, what's 1952? Okay, you can run that. Okay, and then so this is what we have. So 1952. See, this is kind of wild. I wonder. I don't know who this was. GDP per capita was over $100,000 in 1952. That must have been some kind of like resource-rich country where they like just discovered, I don't know, potassium or something. I don't know. Yeah, question.
This is something you said a little earlier, but for the like after gapminder, like straight up line.
Yeah.
Other symbol on DataCamp, it was like the percentage symbol, and then like greater than, and then another percentage. Is that the same thing?
Yeah. So this is so this was the first pipe. The first pipe that was introduced was the percent greater than percent. Okay, and then later on, R used the native pipe. So this was, you had to load a package to use this pipe, and then R now includes this pipe without loading any kind of packages. And there is like a technical difference. They function 99% of cases the same, okay? But yeah, you will see this pipe symbol, percent greater than percent, as a pipe, and then you'll also see vertical bar greater than as a pipe also. But they're both pipes. There you can use them interchangeably in 99% of cases. Yeah, question?
The equal sign versus just one.
Yeah, so equal is what we use to make a comparison. So if we want to check if something is equal, that's the equal sign. And then, so equals is kind of, is like the question, is it equal? Is it equal, okay? Versus the single equal sign is an assignment, kind of like make it equal, okay? So this is like year, is it equal to 2007? That's how we filter to and say, I only want the rows where that's true. Is it equal to 2007? If it's yes, keep that row. If not, I don't want it, okay? Over here, it's saying, I want to take the x-axis of my plot, and I want to make it equal to GDP per capita, okay? So single equals is like, make it equal to this. Double equals is it equal to? Yeah, question?
Yeah. So when you like apply some kind of computation filter on the gapminder, does that apply for them whenever gapminder is referenced?
No, this applies only to this operation. So this basically says start with all the gapminder data, and we're not touching that. Okay, we're just saying start with all of it, then run it through this filter where we're only keeping the rows where it's 2007, and then take the result of that and pass it to ggplot. So now ggplot receives only those 142 rows that it kept.
So if you pipe after the filter, it would reference the whole ggplot.
If you omit the pipe, now you have two separate commands. and actually this one is going to fail because it says I don't have any data. Okay, because ggplot needs some kind of data, and if you omit the pipe, it's going to say, all right, I did Gapminder and I filtered it, and here's your result. And now you're saying, do an entirely separate thing, and it's ggplot, and ggplot's going to say, I have no data. Okay, so this links it and says, all right, here's the data, filter it, and take that filtered data and give it to ggplot. All right, let me give you your first view quiz answer. Is D as in dog. D as in dog. All right, so I'm going to expand on this just a little bit. Okay, we're going to take our Gapminder, and now I'm like, okay, well, can we just pick out different continents here? Okay, so it's the same thing. I've got X. I'm making the x-axis equal to GDP per capita, Y life expectancy, and now I want the colors of the dots to be set equal to the continent. Okay, and we're going to run this, and so now it colors the dots according to continent. Okay. All right, and so we can see, you know, like European nations in 2007, generally higher GDP per capita. Oceania, which is, I think, just Australia and New Zealand, and then some Asian countries. And then, you know, other parts of the world, you know, might have lower GDP per capita and things of that. Okay. So, you know, showing kind of, we see, you know, inequalities across GDP, life expectancy, and things like that. Yeah. Oh, no question. Okay. So one thing that is tough is because GDP per capita is what we would say is a skewed data set. Okay. And what that means is that you have kind of a lot of nations that have kind of some lower GDP per capita, and then we have a few nations with some like very high GDP per capita, right? Like if we look at how many nations have between 0 and 10,000 GDP per capita, okay, there's a whole bunch of dots, okay, between 0 and 10,000. How many nations are between 40,000 and 50,000? There's what, 1, 2, 3, 4, 5, only 5 dots there, okay? So you have, this is what we would say is skewed, where you have like a whole bunch kind of on one end, and you just have a few on the other end. So income is like one of the most classic examples of skewed distributions, where it's skewed to the right. You have, and not just nations, but people, right? Most people make less than $100,000 per year, and you have a few people making like $1 million. You know, like you think about someone who makes $1 million per year, and you go, oh, that's a lot of money. Okay, $1 million a year is a lot closer to $0 per year than it is to like $1 billion or like $100 million a year, right? And there are, you know, or, you know, 70 million a year. And there's not a lot of people, but there's people who make that amount of money, right? Or even like 5 million. 1 million is closer to 0 than it is to 5 million, right? And so you have, when you have something like that skewed, sometimes it's helpful to use a logarithmic scheme, okay? So the normal, on a normal picture, what we call linear, the horizontal distance is equivalent, okay? It's additive. So the distance from here to here is 10,000, and each kind of, if we say this is, I don't know, on my screen it's about 1 inch, okay? Every inch I move to the right, I'm basically adding 10,000 to the thing. So we go from 10,000, 20,000, 30,000, 40,000. Every kind of inch I move to the right on my screen. Okay. With a logarithmic scale, what it does is every inch is a multiplication. Okay. And so every inch is kind of like multiplying by 3. And so if you look carefully on mine, it goes 300, 1,000, 3,000, 10,000. The gap between 300 and 1,000 is just a touch wider than the gap between 1,000 and 3,000. But basically, every inch I move to the right, I'm multiplying by 3. So I go from basically 333 to 1,000, from 1,000 to 3,000, and I'm moving just a touch over an inch to multiply by 3 to get to 10,000, and I multiply by like another 3 to get to 30,000. Okay, so logarithmic is every unit you go over to the right, you're multiplying by a number. Linear is you're adding a number. Okay. Yes. Question.
So I think last class you mentioned that if you don't specify a scale, it will automatically take
Yes.
a scale. Like say maybe between 4,000, 6,000, if that's where most of your data falls.
Yeah.
If you do specify like a logarithmic scale, will it necessarily then start from 0, or do you have to specify one to start?
It automatically does everything. So ggplot will try to automatically make decisions for anything you don't tell it. So when you give it a regular thing, it's going to look at the biggest number you have and the smallest number you have, and it says I need to make the bottom side fit the smallest and the biggest fit the right side fit the biggest. Okay, logarithmic, it's doing the same thing, but it just says, okay, what's the smallest number I have? That's got to go on the left. What's the biggest I have? It's got to go on the right. So it tries to. It's pretty good. Sometimes it gets it wrong, but most of the time, 99% of the time, it gets it right, and it tries to make these decisions. If you don't specify something specifically, it just tries to do it automatically for you. Okay, so in this case, I say, hey, I want a logarithmic thing, and so it does the same thing. I just said logarithmic on the x-axis. Okay, and so the argument here is scale x log 10. Okay, and you can kind of change it, and how are you supposed to remember all of these things? Okay, well, I don't expect you to remember all of these things. Okay, there's a few things. The internet search is really great, and now AI tools really great. So you can just say, hey, I'm trying to make my x-axis have a logarithmic scale on ggplot. What function or what command do I need to use? And it'll say, scale x log 10, or it'll probably give you a bunch of options. Okay, and then all we're doing is we're adding that layer to our plot. Okay, there's a couple things that students sometimes get messed up, right? For the data, we use pipes. Once we're in ggplot, we use plus signs to add layers. Okay, so I've got pipes to say, here's my data, let's filter it. And then we pass that filtered data to ggplot. And then once I'm in ggplot, now I add layers to my plot by using plus signs. Okay, and so this is kind of our scale thing. And so we see, okay, now we can see kind of different income levels for different nations. And we see, even within each continent. So like in Africa, okay, you look at GDP per capita, and there's a wide range. Okay, some nations have higher GDP per capita, and others have lower. All right, in Europe and Asia and things like that, you also have kind of spread in all of these things. It's some of this gets lost when it's without kind of the log scale there. Okay. Another kind of thing is that all of these dots are a different nation, but we also know some nations are more populous than others, right? So you have these small nations, like in Europe, you have like Liechtenstein or something. Okay, it's just this tiny nation. I don't know how many people there are, but it's really not a lot of people. Okay. But they are some dot somewhere in here, okay? And then you have these other nations, much more populous, okay? So China and India are like the two most populous nations, but wherever so we might want to just kind of indicate that, okay? And so here, I'm going to associate the size of the dot with population. We're going to just kind of add another variable to our mapping here. So basically, I've got the same thing as before, and now I'm adding population as to the size here. And so here we have this, okay? And we can see, I think in 2007, I think this is China and this is India, right? It's like almost 20 years ago, so this data is, getting outdated. But, we have different sized dots. for this and kind of some indication there. Okay. There is another thing that we can use, all right? And this is called facet wrap, okay? And what facet wrap will do, okay, is it is going to create like a bunch of like the same plot, but just kind of like all side by side. So what I'm gonna do here is I have this is for 2007, okay? And if I wanted to do this, I could kind of just change this year 2007, and I can do 2002, and I can filter that, okay? And then I can go, okay, 1997, all right? Because I think it's like every 5 years. And I can go through and I can filter each of these to different years and produce slightly different plots, okay? But that's kind of tedious to have to do a whole bunch of times. So what I can do instead is I can create a facet wrap, right? And so here, I'm going to create a vector, all right? And this is going to just contain a few years. I've got every 10 years, 1957, 1967, 1977. So I've got 6 different years that I want to look at, okay? And then now, when I do the filter, I use this command, okay? I'm going to do %in% selected years, okay? So you don't want to do equals equals, okay? Because equals equals is only really good if you just have one value to check, okay? Here I've got multiple values and I just want only the years that are part of the selected years. So we use %in%, okay? And so this is going to just filter to these years. I'm going to pass that on to ggplot, okay? Now, let me just show you what will happen if I do it without facet wrap. Okay, so without facet wrap, it's basically kind of this plot, right? It's this plot, but 6 times as much dots, right? So each nation is now appears 6 times because we have, you know, China in 2007, China in 1997, China in 1987, and so on and so forth. And, you know, the United States in 2007, et cetera, et cetera. And so this is kind of hard to read. But what we want to do is I want one plot for 97. I want one plot for 2007. I want one plot for 1987. And so that's where the facet wrap comes in. Okay, I do plus, I do facet wrap, and this feels a little weird, but we use a tilde and the variable that we want to kind of split on. Okay, so I do tilde year. And what that does is it creates basically, you know, I have the plot for 1997, I have the plot for 2007. You can click this little pop-out button right here. And it should re-render. I don't know why it's not. Okay, usually if I resize, it will re-render it. Okay, there we go. So I just have to let the computer think. Okay, so it re-renders it, and then so now you can kind of see, all right, this was basically the plot in 2007, the plot in 1997. So it does what we did, okay, where, you know, if I wanted to see like, okay, what was it like in 1957? So we have this plot right here, and that's basically this one right here. And then, you know, 2007, we have this plot down there, okay? So that's the facet wrap, which is kind of nice, okay? All right, so again, still kind of a lot of countries. So let's say we were just interested in just a handful of nations, okay? So here I'm doing US, China, India, Japan, Canada. I just arbitrarily selected some nations here, okay? So I'm going to filter, and now instead of doing year equals to these things, I'm going to do country in these selected nations, okay? And then I haven't really talked about arrange, but this is kind of like sorting it. It's going to order our data by country and year. And then here I'm going to add a path to connect all of these things. So just, so this is going to include kind of all of our data. And so we can see like, this is not all of our data, but just for these 6 nations, okay? So we could see like India in 1952, its GDP per capita, I don't know what this would have been, maybe $500-600. And as time went on, GDP per capita climbed, okay, to around 3,000 to 2007. And we can see also made big improvements in life expectancy, starting from below 40 up to 65. Okay, similar things in other nations. Yeah, question.
Is there a reason why you put the size equals pop and the aesthetic for geo point versus GPI as you did before?
Okay, yes. Because if I put it in if I put it in ggplot, it's going to get inherited to geom point and geom path. So geom path is basically the line that connects them. Okay, and so yeah, let me just kind of like if I move this, okay, and I do a size equals pop, then the path itself inherits the size, and so it goes from thin to getting thicker as the path. So this is in my opinion not as pleasing to look at. Okay, so in this case I only want the points to indicate the size, and I don't want the thickness of the path to indicate the size. Okay, but I do kind of like the path to kind of show like, oh, this is like the progress over time. And I'm not exactly sure what happened in the history, but in China, it actually life expectancy went up and then it dropped back down, and then it continued to climb up. Okay, and so there, we have kind of these different paths, and we have this, but this is just kind of like a brief exploration. I feel like there's the data is like kind of interesting, and you can kind of just play around. Okay, so just take this Quarto document and just kind of play around, and you don't have to, you can render it, but you don't have to. You can just kind of click the little play button as you make some of these changes, and just see like, okay, what if I wanted to do this? What if I wanted to do that? And kind of go back and forth looking at documentation for ggplot and whatnot. And so yeah, the rest of this week we're gonna I'll cover a little bit more fundamental ggplot things like bar charts and things like that, just because that's also I think like a key fundamental thing. There's lots of geometries in there, but we'll just kind of start with those basics, and then we'll also look at some of the more things that you can do with your data, not just filtering for certain rows, but there's a lot more that you can do, which is going to be good. Oh, wait, how many answers have I given you? Just one? Oh, okay, all right. I got to do my job here. Okay, second answer is E as in elephant is your second answer. And the third answer is C as in cat. E as in elephant is your second answer. C as in cat is your third answer. All right, we'll end here. Have a great rest of your day. If you're having any issues with your computer and stuff, come to office hours. Get started on your homework. Make sure everything works. And we'll see you Wednesday.
Thank you.